Okay, so the first thing I want to do, actually, before I start going over the review, is talking to you about documents that are available to you online. So hopefully while you are looking at this, the substitute is coming around and stamping your review. You can get up to 2 stamps for this review. And then also, um, you can you will also be going over this today in class. But I want to show you these documents that are available to you later today. They are not on my plan book right now, but if you go to the School Fusion page and go to the Lido School Fusion and work your way to my home page or to my AP Stats page, then you're going to see the plan book. And of course, when you see the plan book, you're going to see the Monday, what's going on. And again, tomorrow, you know that it's your test. Now, if you look at tomorrow's or Monday's information, on that is the Chapter 12 and 13 review key. And that is a PDF format. So that is this document right here. And so then it takes you through all of the work that I'm going to be showing you when we go through the work today. All right. Next, you will also see on the School Fusion page Chapter 13 Quiz T. Now those um, are there and are going to be there for you later today. I have taken those off and made those unavailable for obvious reasons, so that we don't have people just copying the key and such. But I do not want you to have to frantically write down all of the answers to this Chapter 12 and 13 review whenever I'm going over it. I want you to be able, you can write down some things if that becomes, just you have a few things you want to write down, but you shouldn't have to frantically write down all the answers, because later today you can have your own copy of that if you so choose. All right. So, with all of that being said, here is the start of the review. Okay, the first part has some free response on it. I'm not going to try to go over this too terribly much. This first problem, let's kind of review that, is about the laundry detergent, which cleans better. You have 120 pieces of dirty laundry available for the experiment. So, identify the subjects, explanatory variables, and response variables. So the subjects are the 120 pieces of dirty laundry. The explanatory variables, they actually said in there that they are going to do type of detergent and temperature of water. And I think we've seen that on a problem before. So does one brand work better in both hot and cold water? And which one of the two brands of laundry detergent, brand A or B? So that is two explanatory variables that get assigned to the laundry. That is two factors, if you want to say. Two factors. The levels for the detergent are two. There are two levels for detergent, brand A and brand B. There are two levels for water temperature, hot and cold, which that makes 4 experimental groups, treatment groups altogether. So if we take a look at this, then you can see that there are then 4 treatment combinations. Oh, by the way, the response variable is the cleanliness of the clothes. And you may be averaging that if that's on a scale that somebody is judging. But you can have brand A with hot water, brand A with cold water, brand B with hot water, and brand C with cold water. So if there's 120 pieces of laundry, then if you did a completely randomized designs where you just straight out put them into the treatment groups, that's 30 pieces of laundry for each treatment group. Now, it asks then for you to do some kind of design. And so here's what I decided to do. And again, you may have decided to block by a different method. But what you have to do, if you choose to block, is by you are deciding to take a trait that the subjects came into the experiment with. So I thought that laundry is mostly divided into lights and darks. And then also reds. Okay, actually, I do 3 loads at home. I will divide them into dark colors, the light colors, and the white colors, and then the reds. So over here, I put that I will block by colors because I think that that clouds the effectiveness of the cleanliness of the treatments. It may be able to, maybe the darks look cleaner than the whites. They get cleaner that way. All right. Now, notice I do not have a number here for the um, darks, lights, and such, because so I don't have a number right here because I don't know how many darks, lights, or reds that there are. I knew there were 120, but if I didn't just do a completely randomized and I blocked, I don't know how many are in the experiment. Now, I'm going to do a completely thorough job right here on one of these blocks. I'm going to take the darks. I'm going to randomly assign, and I'm going to take a fourth of the group and put them in the brand A with the hot, a fourth of the group, brand A with the cold, a fourth of the group, B with hot, and a fourth of the group and B with C. See, and I don't know how many that is. I'm just having to take this fourth of the group. Now, the way that I did this random assignment was within each block, I followed part C above with the randomization procedure. So let me read what I had put up there. I don't see randomization procedure, so I should probably fix that. This, then, I guess, needs to say something like the big bag situation, where I'm going to put all of these darks into a big bag, and then I will, oh, yeah, here I did. I see it, I see it, I see it. Here we go. I'd put each block into a laundry bag, mix well, and then pull out a fourth for each block for each load. Okay, and there's the mix well so that you have the randomness. Okay, good. So that's in there. Then I'm going to measure the average cleanliness for each treatment group. Okay, and for each treatment group, and then I will compare those average cleanliness values. And so that I do not have to write this over, I put repeat experiment for each block right there. Okay? All right, so that's first problem. Second problem is the problem about the nurse practitioner versus the doctor. And so what happened was when you first read this, it mentions how it takes the 16 patients and had no regular source of medical care, so that's, they're all without regular care. They put 510 with the doctor and 806 with the patients. Now, from the way this it says that it took the experiment assigned 13 and 16 and it split those up. Now, it does mention here, and this made it confusing, I'm not able to tell, it does mention that patients had been diagnosed with asthma, diabetes, or high blood pressure, but I really did not have any indication if they had blocked by that first. So they did not say that they first divided the patients into those groups. They say that first they go ahead and just, it looks like they randomly assigned them to the treatment groups first. Okay, so because of that, I had to go with completely randomized. And what are the experimentals? See, it sounds like completely randomized because we didn't know if they actually did do the blocking by asthma, diabetes, or high blood pressure. The experimental units, of course, are the patients, and then the treatment that is assigned to them is the physician that they get assigned. So either the doctor or the nurse practitioner. Now, the concern that I would have is that we did not know they were randomly assigned. I guess we kind of have to assume that random assumption that the experiment was done correctly. And it seems as though the patients were not assigned with equal number of patients in each group. So that was kind of strange. I don't know if that had to do with working hours. Maybe the doctor's going and doing surgery, so he actually did not get as much as the nurse practitioner. Maybe at the beginning of the time period, slips of paper were put in a big bag. Numbers of paper corresponded to the number of spots available for each physician. See, because if the doctor had surgeries or he did not have any more available spots, and so on. So as a patient called for an appointment, then a piece of paper would be drawn out indicating which physician the patient would be able to get an appointment with. So that's one of the ways that you could do that assigning of the random to the treatment. How should they be randomized? Of course, you know, if you think about this experiment and if you think about continuing with it, you'd probably want to say not let the patients know if they are seeing the actual doctor or the nurse practitioner, because I don't know if that have an effect on if they think they're getting better or they're getting better care and all that kind of stuff. But that's actually a whole different situation. They didn't even go into that with this question. So let's move on. All right, the next one is about Dr. Dogs diagnose cancer by sniffing it out. So they talked about getting the people with their handlers, and the dogs would lay down. Now let's talk about what was happening, because what they would do is they had it such that both the dog handler and the observer to identify the breath samples, they were both blinded. And so explain why this blinding is important in the aspect of this experiment. Well, I mentioned to you with the situation with the dogs, you consider it blinded if the handler, the single blinding, and the blinding would be important so that the dog handler or the observers do not unconsciously or subconsciously, whatever, give off any signs to the dog as to the type of cancer that the person whose breath was being smelled had. And of course, you wouldn't want the person with the cancer or not. So the person being examined, the treatment, I guess, the person being examined, you wouldn't want them to know if they had cancer and such. And really, you don't want them to know what the dog's response means, because I would imagine that you don't want them to get word of cancer through a dog laying down. So, but that's why it's important to blind both of those, because they would have a psychological impact upon that dog. All right, and the last one is about the bee pollen, and there's two different methods. The Plan A had this situation where you had 200 women. Some took bee pollen and some did not. Okay, and so then they just followed them. So essentially, this first plan is an observational study because you just identified what the women were already doing. Whereas in Plan B, they took women and they assigned them a treatment, either the bee pollen or the placebo. Okay, so they either did the bee pollen or they did the placebo. So that's assigning a treatment. And then they followed them for 5 years. So because one is an experiment and one's an observational study, you have a difference in what you can conclude. So therefore, Plan B would be a stronger result because you can infer cause and effect. And more trustworthy conclusion, stronger. The only difference between the patients was the treatment. So that would probably be a better choice if you were wanting to make that kind of claim. All right, so on to the multiple choice. All right, with number 1 is B. The first statement was an observational study because they didn't have a treatment. The second one, the people were assigned. They received a treatment of niacin or a treatment of the placebo. So the second was a controlled experiment. Number 2. All right, so they wanted to study the effects of this temperature. So this is the factor. That's the experimental unit. Okay. They wanted to find I'm sorry, that is the explanatory variable, and there was just this one item that they assigned to the people, and so they took this one item and they did that in 4 different levels. Okay, so temperature of the paint that the pain reliever was stored in. All right, so there were 4 treatments. The experimental units were actually the pills. Those were what was being studied. It was not the people. The pills were placed into different temperatures for storage time. Okay, so it is the pills that were the experimental units. Now, the response was based off of the time, and it said right here, the time it took to gain relief from a headache. So the response was actually measured in the person, but the experimental unit is the pill. All right, so that's why it's choice A. Next is D. This legacy groups of this school is kind of like taking a homeroom, but what they did was, since they described selecting one student from each of those groups, that's like saying one from all or some from all, and so those would be stratified random sample. So because they took some or one from all, that's stratified. Clustering would have been if they picked one of those legacy groups and sampled all of it. Took one or a few of those legacy groups and sampled all of it. Now, I have some issues with this next one. I first chose B, but then after talking with students about it, some of them convinced me of E. So we can talk through those. I think that if we have the politician standing there in front of the grocery store, then that's the response bias. That is just like the man standing there at the people with our video saying, "Do you think you can trust men with mustaches?" But there would be some kind of bias on the response because they feel like they need to tell her that they know her. Now, if you just placed random posters in front of the grocery store, okay, so I think the attempt of having every grocery store was an attempt at making sure you're getting all types of people. But I think that students in the past had argued that that was also under coverage because you're only getting types of people going to the grocery store. But where on E, if you gather a random sample of eligible voters in the district, see, that does sound quite a bit more like you're trying to get an appropriate sample. You want to make sure, though, that when you visit their homes and you ask them, that you do not have wording bias to provide interviewing or the wording of the question making a response bias. So I thought that either one of those, and probably if E was done correctly, it probably is the better choice because the actually B could have more under coverage than E. All right. Next, which would be unreasonable for a census. If you're just going to talk about the houses in your neighborhood, that's going to be okay for a census. If you're just going to be talking about the engineering professors and the proportion of business professors, that's going to just be a small enough amount that you can take care of sampling all of those. The construction workers in a small town, that is okay. The students with a learning disability in a small rural high school, that's okay. But as you can probably tell, getting the proportion of red snappers with high mercury level in the Gulf of Mexico, in order to do a census, you would have to get all of the red snappers, and that is not reasonable for a census whatsoever. So B is definitely the one that's not reasonable. Okay, on 7, the quiz that the students take is the treatment. So that is what makes this an experiment, okay? So the teacher is giving them A, treatment of the quiz. And so because he did that, then I eliminated C, D, and E. Um, and since that would be an experiment, then you do have the ability to make a cause and effect conclusion. So B is that answer choice. All right, number 8. Let's see. So what happened here is they were trying to make a generalization to the entire all of the customers. So they wanted to get a generalization about all US customers from just sampling the customers in Arizona. So I don't think that that's reasonable because I think one state is not going to be necessarily representative of all the states. So I think that that is not a proper method of sampling because it's only coming from one state. All right, next, number 9, they were randomly assigned. The 30 patients went straight out into the treatment groups of the currently marketed medicine and then the other experimental medicine. So going straight into the completely randomized groups is, or into the treatment groups is the completely randomized design. Matching pairs or blocking would be involved, like maybe separating them by age or pairing up patients based on like qualities such as race, age, and so forth. All right, so number 10 is E for the answer. You can see the answers on the next page. The patients were randomly assigned to one of the two treatment groups. That's a completely randomized design. And I think that what happened on the answer choices on this is they tried to trick you and say that when patients were wearing a blindfold that they were blinded. But that is not the definition of being blinded. So no, that does not hold true. Therefore, this experiment cannot be double-blinded because the patients will know which treatment they are receiving, even though the doctor may not. Okay, so it can't be double-blinded because the patient will know if they are whatever the two possible things are, taking the pill or doing the exercise, whichever that was. All right, next, D is 11 because this all right, so what happens is whenever you are studying this, you are not assigning a treatment for one. Okay, so if you're not assigning a treatment, then you cannot do cause and effect. All right, so this study was not an experiment, so cause and effect cannot be warranted. So C is good to go, C is true. Okay, the child's location, of course, may be a confounding variable, and then how the driver is driving could be a potential confounding variable. Concluding that the seatbelts save children from injury, you cannot say that because that's essentially saying cause and effect. But you really have to, let's see, concluding that seatbelts save children from injury is risky. See, that is risky because essentially you can't do the cause and effect, so that is true. The one that is false is D. It says this study demonstrates clearly that seatbelts save children from injuries. That statement is essentially saying cause and effect, and it's also stating that it is a fact that it saves lives. And it does not necessarily in all case. Now, it did in 5% more case in this study, okay, but it's not factual. So D has to be the one that is false. All right, here with number 12 is C. It is invalid because the changes in the water usage due to the shower heads are confounding with other variables. I don't think that in this study that they had they didn't have a control. So to me, that was a concern because what if you went from August to September or September to October? You may be using less water anyway just because you're watering less outside. So if you don't have a control group to see what kind of change is happening without this treatment, then you don't know if there are other confounding variables happening, okay, that you needed to control. So that's what happened on that one. And E, do be aware that you are going to have these kinds of problems that have the 1, 2, and 3, and 1 only, 2 and 3, and that kind of stuff thing. Those are AP type multiple choice questions, okay? So you need to be prepared to go work yourself through those. Now, with this one, you did not need a third type of exercise because more treatments do not necessarily yield more reliable results. Getting a correct sample that is representative, controlled experiment that replicates is the way to have a good experiment. So a control group that does not exercise in order to determine if it is an increase of productivity, that would be a very good thing to kind of have a control group to compare against to see if there was just general improvement in the company without that treatment. Furthermore, they do not mention the random assignment of the employees. They allowed the employees to choose the type of program. See, they allowed the employees to choose the program that they wanted to participate, in which they wanted to participate. If you do that, then they're essentially volunteering into that program. Maybe the type of employees that volunteer into the exercise program are a different quality of employee than just the general quality of employees in the business. So you cannot have them place themselves into that experiment, into the exercise treatment, if they want to generalize to the whole company. You would have to randomly assign the employees to the treatment groups in order to do that further generalization. All right. And 14, okay. This one was about saying that just because you have a large sample does not mean that it can overcome the bias. We learned, we've had many examples, including starting from day one with the bear hunt lab, that if you get a bigger sample, the bias is not necessarily going to go away. Continuing to do that same bias in the same method is still going to occur just even on a larger scale. Okay, so if you do not rearrange the way that you design the experiment, the bias will not be overcome by a large sample. All right, now the last one is one where you do show a design. It did say to make a completely randomized design. So that means you took the 40 undergrad students and you completely randomly assigned them to the treatment groups. No blocking at this time. So I did the random assignment. All the 40 student IDs are put in a big bag, shake well, draw out the 20 ID numbers to indicate the students for the cell phone group, the others to go to the no cell phone group. Okay, so we had 20 randomly assigned to each group. They go through the driving simulator, and then you measure the average time to break. So this is the response that you are measuring for both groups. You then compare that average time to break. All right, so that's a completely randomized design. Now B says, what's the purpose of the randomization in this study? You were trying to hopefully distribute all traits of the students equally. So experience, intelligence, any traits that is pertinent to the response, which is the reaction time, will be spread evenly and biased across both groups. All right, now, part C says that they have concerned that there is large variation amongst the people. So they want to do some further control to reduce that variability amongst the two groups. So the issue is that they said there's driving habits, skill level, length of driving experiment, etc., etc. So with multiple qualities that need to be controlled, one single blocking does not seem ideal. Just doing men and women, or just doing experience time, or just doing driving habits. One single block is not enough to control. Therefore, I made the decision to do a matched pair design and match the drivers by closeness of the above traits: driving habits, skill level, length of driving experience. And then after pairing, one member of the pair is randomly assigned to the cell phone group, and the other is goes to the no cell phone group. I probably should have put in there, I will flip a coin for one member, and if it gets tails, it'll go to the cell phone group. Heads, it'll go to the no cell phone group or whatever. So I probably would have best uh, it have been more careful of me to go ahead and describe that randomization procedure. That's always something that don't want to leave out just through laziness and then get that counted off. All right. So again, I will be at school in the morning. And you can also ask me some quick questions if you just had one or so really quickly before the test. Okay, but please do not forget that you can go to the website, to the School Fusion page. After school today, I will put these on here to be able to be displayed for you so that you can get the printout of the answer key and also see how I graded those quizzes that you got back today. All right, good luck with that. Thank you.